Let's go to equal 2641 cousins in binary tree. For this question, it gives us a binary tree, and let's replace the value of each tree, each node in the tree with the sum of all of its cousins' value. So, what is a cousin? Two nodes of a binary tree are cousins if they have same depth with different parents. So, for example, we have a tree, right? In one layer, these two, they belong to the, they have same parents. This node has left and the right. And this, they have same parent. This has same parent, right? Then we call these two, they are not cousins. These two, they are siblings, right? Sibling. And we'll say this with any of this, they are cousins, right? Or we'll say we can pick a particular this one with this, they are cousins. So what we want is that we want to replace, for example, replace this value with its sum of its cousins, right? So if this value, let's say this value is also this part sum, right? So intuitively, what we're thinking about is that we can get some of a layer using BFS easily, right? To get a sum of each layer. And also, if we know, for example, know these two siblings sum, when we traverse, right? We can use a level sum minus sibling sum. That will be the cousin sum, right? But since that the sibling in the same level, we don't know whether these two nodes they are sibling or not, right? We can only from its parents know its left child and right child they are sibling. So that means that we can do thinking out of box instead of calculate a current layer to update the value of the current layer to get a current level sum minus current sibling sum. We can iterate from the, for example, from level I to calculate level I plus one, right? That means because in level I, we know a node, its left child and the right child, they are sibling. So every time, so that means that when we BFS, right, BFS, we BFS get every node, we get a sum of next layer. We call next level sum, right? And also, if we, so this is the first time we iterate every node in level I, and we need to also need to update those kind of nodes in level I plus one, right? Because level sum is level I plus one level sum. So we can store every node in a buffer, right? And and uh, and we iterate those kind of nodes again at level I again. And for every node get its child sum, right? So for example, we are sitting here, then get the sum of this and this, right? And the next level sum is this layer's sum, right? So for each child, just after the value to be the next level sum minus these two value, these two sum, right? So this node the child sum, right? Value. So doing like this, right? If we include the root, what we update is from the level one, right? We never update the root. because we sit at a layer, we are always update the next layer. So we can either after we do the BFS set root to be value because it will be 0 for the root, set root value to be 0, or we can use a dummy node at the top, right? So let's write up the dummy way. We are going to have tree node dummy equals new tree node -1. There is another advantage is that if it is we use dummy node, even this root is none, it's still fine, right? Because in the end, what we return, we'll set a dummy dot next equals root. In the end, we just return dummy dot next. We're going to have q node q equals new array deck and q offer dummy. Let's say, wow, this queue is not empty. As we talk about, we need a list to store current node, right? The layer of current node we call list equals new array list, and we have int n equals q dot size, and we need a next level sum, right? There. So int I equals 0, I smaller than n, I plus plus. So we have tree node current equals q dot pull, and we always have this at current. So the thing is that this list is at the level i's nodes. And the next level sum is calculated the level I plus let's say possibly this level j, okay, and this j plus one's sum, right? So that is, let's say, if current dot left doesn't equal to none, we are going to have of course we can we need a q dot offer current dot left, right? And also we need a next level sum should pass equal to current dot left value. And we say if current dot right doesn't equal to none, we can q dot offer current dot right, and the next level sum should plus equal to current dot right dot value, right? And what we need is that we are going to update the next layer value, right? So how can we update the next layer? That means that for next layer, we can not tell two nodes are sibling, but we can from current the nodes from current layer list to get its child, two childs, right? And to update the sibling sum of the child. So what we do is that for p node in list, right? We're going to have for this node, we're going to have its child sum. This child sum will be its left child plus its right child. So for the left child and the right child, right? The to those nodes, we'll say that is their sibling sum, right? Equals node dot left. If done if this one equals none, right? If this one equals none, then we'll set a 0. Otherwise, have node dot left dot value plus node dot right equals none. and then zero, otherwise know the dot right dot value. Right. So this will be if it's we update its left and right chart. So if we node dot left equal to now, node dot left dot value equals next level sum, right? Minus child sum. And yeah, and let's say if we node dot right equal to now, then node dot right dot value equals next level sum minus child sum. Also called children sum, right? Because there are whatever. And in the end, what we want is return dummy dot left, right? It's an ON time complexity. In the space, we have a queue, right? So, so we'll see for binary tree, um, we are for the what's the it will every time will get every layers nodes in the queue, right? So in the last layer, it will be about half load nodes. So it will be ON space. Um, let's write Python code. We also need a dummy equals tree node with minus one, right? And we have dummy dot left equals root. We're going to have q equals dqe. Convert this list as d deck, right? Dummy. But say why this queue is not empty. So we need n equals length here, or we can call size, right? So next level sum equals zero, right? And we need a list to current level nodes, right? Current level nodes to add current level node. So what we do is that for in range and we need a current equals to q dot populate. Populate. And we need a current level node append current. So let's say if current left is not a null, right? We're going to have a next level sum should class equal to current dot left dot value. And if of course we need a queue append current dot left. We also say if current dot right is null, we have next level some class equal to current dot right dot value. And we need a queue dot append current dot right. We use a current level node. We need to iterate that to update its children. Right? So we say for node in current level nodes show the child sum equals um, so I say node dot left dot var value if node dot left is not null, else there plus node dot right dot value if node dot right else. Yeah, right. So if node dot left is not null, we'll have node dot left dot value equals next level sum minus children sum, child sum. And if node dot right is not null, node dot right dot value equals next level sum minus child sum. In the end, return dummy dot left